understanding the concepts of movable pulley. We have fixed pulleys, we have movable pulleys. Now when we talk about the fixed pulleys, they primarily they are at one place and they purely rotate. They have a pure rotation only. Whereas when we talk about the movable pulleys, they rotate also and they translate also. That is, there is a translatory motion also. Let's take this case. This is a fixed support. From this fixed support, a fixed pulley is hanging. That is, it can only rotate. It is fixed to the fixed support, so it can only rotate only. So this is what we call as a fixed pulley. String is going over here, the mass is there, this and this. So string goes like this and it is fixed over here. When this block goes down, then certain length of the string is constant. So when this block goes down, this pulley shall be moving up and this shall be rotating also in this direction. So this pulley is a movable pulley because this can rotate also and this can translate also. Similarly, if we look over here, this is a fixed pulley. This is a kind of a support. This is a horizontal surface, there is a block, and this is a fixed pulley. This can only rotate. So when this mass it goes down, this pulley shall, because this and this is one string, so as soon as this goes down, this pulley will be moving in this direction. When this pulley will moving in this direction, then certainly one end is fixed. So this block will move in this direction. So as a result, this pulley shall be rotating like this and this shall be moving like this in the forward direction also. Similarly over here, if we see that this is a one fixed pulley and this they are the movable pulleys, because when suppose this block is going down, then this pulley will be rotating and going down, and from here to here we have one single string. So as soon as this pulley goes down, then this will pull this pulley up. So this pulley will be moving in this direction. This will rotating also and translating also. So we have D and F as movable pulleys. E is the fixed pulley. Similarly over here, we have Y as the fixed pulley, X is the movable pulley. If we talk about this, A is a fixed pulley and B is a movable pulley. If you look at these, you can easily say that is which is a fixed pulley and which is a movable pulley. Now we are considering a case where there is a movable pulley and over here there is a mass and we pull this center by distance x, and it is asked by what distance now this block will move when the other end of the string is fixed like this. The important concept in cases like where there is this movable pulley, one end is fixed, on the other end there is a mass, and if this is pulled by x, then the important thing to understand is that is if this is pulled by x, this block will move by 2x. That is, if this moves by some distance, this will move by double the distance in the same time. If we divide by d, that is dx by dt, so it means if at any time the velocity of this center is v, then this block will have double the velocity, and once again if we differentiate, it means that is if its acceleration is a, it will have a acceleration double the acceleration of this, that is it will have acceleration 2a. Let's see how it happens. We take a simple numerical values and we try to understand, that is if this moves by 1 meter, this will move by 2 meter. That is what we mean by x and 2x. Let's say the length of the string is 18 meter, that is we take it as 18 meter. All these, they are the point masses, pulleys, point mass, and this is also a point. So we are not bothered how much string is consumed over here and what is the distance from here to here, all those things. That is, we are for convenience, we are taking all these bodies as point mass bodies. So the length of the string is 18 meter. In this arrangement, let's say this length is 10 meter. So obviously if this is 10 meter, the total length is 18 meter. So it means that this length is 8 meter. This is 10 meter, this is 8 meter, this is a point mass body. So obviously its dimensions, they are almost equal to 0. So it means this is 2 meter. That is, right now the block is at a distance of 2 meter from this wall or rigid support. Now what we do is we pull the center of this movable pulley by 1 meter. So as a result, its center from this level, it goes to this level. It comes over here. When it comes over here, so obviously now the string will pass like this and this block will move in this direction. So we see that this length is 1 meter, this distance is 1 meter. From here to here, that is 10 meter, so it means from here to here this will remain as 10 meter. Plus now if this is 1 meter, so it means from here to here is also 1 meter. So this is 10 plus 1, 11 meter. Total length of the string is 18 meter. So from here to here, initially it was 10 meter, we have pulled by 1 meter. So length on top side is 10 plus 1, 11 meter. So if this is 11, so this means this is 7 meter. 11 plus 7, that is 18 meter, is the total length of the string. If this is 18 meter, now from here to here it is 11 meter, 10 plus 1, 11 meter. From here to here is 7 meter, so it means now this should be around 4 meter. This is 11, so obviously this is 11. If this is 7, so this distance is 4 meter. So it means now the block is at a distance of 4 meter from the wall. Initially it was at a distance 2 meter. What we have done is we have moved in this arrangement where one end of the string is fixed to the wall, this is movable pulley, and over there is a block. So now what we have done is we have pulled the center by 1 meter and we have seen that this block has moved 2 meter in this direction. Initially it was 2 meter distance, now it is 4 meter distance. We have pulled it by 1 meter. So it means if we pull the center by x meter, so this block will move by 2x meter. If we divide by t, that is x by t is distance by time, is speed or velocity, or we can say dx by dt, that is velocity. So if we divide by t this way, so this is also divided by t. If this center goes from here to here in time t, then obviously this block will also move 2 meter in the same time. It will take the same time. So it means if we say x by t as v, and then certainly it has moved 2x, so 2x by t, x by t is v, so this is going to be 2v. Similarly, once again if we differentiate, then we say that is if acceleration of this center is a, then it is 2a. So what we understand from here is that is in the arrangements like this, where there is a movable pulley, string is passing like this, one end of the string is fixed, and from here if it is pulled by x, so this will go by 2x. If this goes by v, this will move by, it will have a velocity 2v. If the acceleration of this center is a, then the acceleration of this block will be 2a. Also, we need to remember our earlier case which we had done in our earlier classes, that is the tension in this string which is passing over the pulley, if that is T, then the tension in this central string which is supporting the pulley or which is going through the center, it is double of either tension. So if it is T, then this tension in this central string is 2T. We shall be making extensive use of this result and this result in solving our questions on movable pulleys. We can also get the same result by very elementary use of calculus, that is through differentiation we can establish that is if this block moves by a distance x, then this block will move by a distance 2x. If this pulley has a velocity v at any instant, then this block will have a velocity 2v at that instant. If this pulley has a acceleration a at any instant, then this block will have acceleration 2a at that instant. What we do is we take this length, let's say from here to here as x. From the wall we have taken the distance to the center of the pulley as x, and from here to here, that is the block is at a distance y from the same wall. The length of the string is constant. So if this is x, this is y, so this is what? This length is what? So this is x minus y. So it means the total length of the string, total length of string is equal to x plus x minus y is equal to 2x minus y. So total length is fixed. So we can say that is if we say the total length is L, so L is equal to 2x minus y. If we differentiate it with respect to time, then dl by dt is equal to d by dt of 2x minus dy by dt. Now L is constant, L is not changing, so dl by dt, that is equal to 0. So this comes out to be 2 dx by dt minus dy by dt. It goes over here, it means 2 dx by dt is equal to dy by dt. Now what is dx by dt? Dx by dt is, that is the rate at which x is changing. The rate at which x is changing means that is velocity of this. What is dy by dt? Dy by dt is at what rate the distance of this block from the wall is changing. So dy by dt is velocity of this. So we can say that is dx by dt represents velocity of pulley, and dy by dt is represents what? Velocity of block. So when we say 2 dx by dt is equal to 2 dy by dt, it means 2 times dx by dt is what? 2 times velocity of pulley is equal to, that is dy by dt. Dy by dt is what? Velocity of block. That is, velocity of block is double the velocity of pulley. Similarly, we can differentiate it once again and we can get, that is, acceleration of this block is double the acceleration of this pulley in this direction. Let's use this concept to solve the questions on movable pulleys. Let us take a question where we have one fixed pulley and one movable pulley. Suppose we are asked what is the acceleration of 5 kg block. This is, we have to find out. So we make use of the concept which we just understood, that is, if this is a movable pulley, if this goes by A, this will go by 2A. Also, in this string which is passing over the pulley, if the tension is T, then in the central string the tension is 2T. Rest is all simple. Whatsoever we have done in laws of motion, we have drawn the free body diagrams, we have done the question of pulleys, then rest is we just apply and we can get the answer. Like over here we write T, and in this string, obviously this is central string, so obviously the tension over here is 2T. This from here to here there is a one string only, so tension in this also is 2T. So what we do is we draw the force diagram, we draw a circle onto this, we isolate this body diagrammatically, and now we shall see that is what are the forces which are acting on it, and then we will apply F is equal to ma. That is how we had been doing the force diagram, how we had been applying the free body diagrams. We draw a circle onto this, T is in this direction. We have x-axis, we have y-axis. Over here, that is m into g, we are taking g as 10 meter per second square for the ease of calculations. So over here it is 2T, that is tension is outward away from the body. So onto this block which is hanging vertically, this is 100 Newton is the downward direction, 2T is the upward direction. From here to here it is 2T, in this string it is T. For this block of 5 kg which is moving purely horizontally, it means the forces along the y-axis, they are balanced, that is its mg is going to be balanced by normal reaction, so there is no need to draw those forces. So the unbalanced force onto this is T. So for equation for this is going to be T is equal to mass, that is T is the unbalanced force. Now we are making use of F is equal to ma. That is the third step of free body diagram method. So the force, unbalanced force, resultant force onto this block in this direction is T. Force is equal to mass 5 into now acceleration. What is acceleration? If this block goes down with the acceleration A, from here to here, this is one string. If this string is pulled with the acceleration A, then this is one string over here, be it a pulley, be it a block, whatsoever it is, it will be pulled with the same acceleration. If this block goes down by 1 meter, from here to here there is only one string only, inextensible string. So if it goes by 1 meter down, then this block or pulley, whatsoever the thing is over here, that shall also be pulled by 1 meter. Over here we have a pulley. So now if this goes down by A, so it means this center will also be pulled with A. If this is pulled with A, if this is pulled with A, this end is fixed, so it means this will move by 2A. So it means this block will move by 2A. So equation for this is T, force, is equal to mass into acceleration, 2A. This is one. For this, it is 100 is downwards, minus 2t, it is acceleration downwards, so downward forces minus upward forces is equal to mass is 10 into acceleration. This is equation number 2. So obviously, we can put t is equal to 5, that is 10 into 100 minus, this is 10a, we can put t is equal to 10 over here, 2 into 10a is equal to 10a. So this is 100 minus 20a is equal to 10a. So 100 is equal to 30a. So a is equal to 10 by 3 meter per second square. So this is the acceleration. Please note that this acceleration is of this. We have found the value of a. Acceleration of this block will be 2 into a, that is 20 by 3 meter per second square, because the value of a is 10 by 3 meter per second square. Once you identify this unit in your question, then you have to just use the relationship, that is, if this moves by a, this will move by 2a. If this is t, this tension is double, that is 2t, and you can make use of F is equal to ma. You will write few equations, then you can solve to get the answer. Let's say we have a question like this. Over here, we see two movable pulleys. One is, if we just focus on this, so this is a movable pulley. And then is, if we just focus on this, this is another movable pulley. Our first step will be in establishing a relationship between the different blocks, which is moving with A, 2A, etc., and where the tensions they are T, 2T or T by 2, that whatsoever the tensions. So we shall be establishing the relationship between the tensions and then between the acceleration of various blocks. Let us say that is tension in this string is T. If the tension in this string is T, the T is throughout same, then the tension in the central string is going to be double, that is 2T. If the tension is 2T in this string, so this string is passing over this pulley, so this is sideways string, so it means the central string, it is going to be double the tension of either of the strings. So it is 2T, 2T, the 4T is here, the pulleys they are massless. If 4T is in this string, from here to here it is the same string, so over here also the tension is 4T. So now, if this block goes down with A, it means from here to here we have a single string. It means the center of this pulley shall also be accelerating in this direction with A. So now we are seeing this pulley, we are not bothered what is tied over here, we are not bothered. What arrangement is over here, we are not bothered. We are just bothered that this is a fixed end and over here there is some movement is possible. That is, we are going to apply the concept of that over here. So if this goes with A, this goes with A. If this goes with A, whatsoever thing is tied over here, that will move by 2A. Over here it will move by 2A. What is tied over here? This pulley is tied over here. So this pulley will go with 2A. So now if this pulley center it goes with 2A, then one end is fixed. So obviously this block will move with double the acceleration, that is, it will move by 4A. So what we have done is, we have established the relationship between the tensions in the various strings and also between the acceleration of various blocks. Rest is, we just write the equations of laws of motion, that is F is equal to ma, that is net force is equal to mass into acceleration. We draw a circle onto this. This way it is 100 Newton, this way it is 40 tension outwards. Equation for this is 100 minus 40, this force minus this force is equal to mass 10 into acceleration. And for this, there is only tension. The motion is not along the y-axis, but it is purely along the x-axis. So for this, T force is equal to mass 5 into 4A. So we have two equations, 1 and 2. We can put the value of T from here to here and we can get the value of acceleration. Once we get the value of acceleration, please don't forget to multiply with 4 to get the acceleration of 5 kg block.